In section 3.3, we're going to talk about function notation. What are you going to learn? You're going to learn how to use function notation to evaluate and interpret functions, how to use function notation to solve and graph functions, and we're going to use them within real-life examples. So let's start with what a function or what a function notation is. So function notation, f of x, that is called function notation. It's another name for y. For example, instead of y equals mx plus b, we could say a function of x equals mx plus b. This notation is read as the value of f at x, so the value of f at x, or f of x. The parentheses do not, this is important, the parentheses do not imply multiplication. It does not imply multiplication. This is not multiplication. Don't ever think it is. You can use other letters. So use whatever letters you want. The most used ones are G, H, J, and K. Would be the most used ways to name a function. Now, using function notation to evaluate and interpret. You know that linear function, or a linear function, can be written in the form y equals mx plus b. By using function notation, we can call it f of x equals mx plus b. The notation f of x is another name for y. If f is a function and x is in the domain, then f of x represents the output. I want you to think of it like this. X is in the domain. This is really just y. Y represents the output. So does f of x. Because it represents the output of f corresponding to the input x. You can use letters other than f to name a function such as g or h. So example 1, let's evaluate a function. So I'm going to move it over here. We need to evaluate this function. Now if we read this, it's important to note this. The notation f of x is read as the value of f at x, or f of x. It does not mean f times x. So we want to find f of x, or the value of f at x, when x is 2 and f is negative 2. So all we do is we plug it in. We want to plug in the 2 for both x's. So it's f of 2 equals negative 4 multiplied by 2 plus 7. So f of 2, or the value of f at 2, is equal to negative 8 plus 7, which is negative 1. Same thing, easy. If I do f of negative 2, I just plug in negative 2 for x. That gives me 8 plus 7, which is 15. So f of negative 2 is 15. F of 2 is negative 1. So here's the fun part. I love these problems. Taking what you know and applying it to real-life statements or interpreting the meaning behind them. So, f of t, we're going to let that be the outside temperature in degrees Fahrenheit, t hours after 6 a.m. So t represents your input. This is your x. This is what you plug in. The number of hours gets plugged in. F of t is degrees. So explain the meaning of each statement. So this means we're plugging in f of 0. 0 is hours. So after 0 hours, we have f of t equals 58, meaning the temperature is 58. So what does that mean? This is our initial temperature. Our initial temperature is 58 degrees. That is not an 8. 58 degrees Fahrenheit. Now, at what time is that? It's our initial height at 6 a.m. B. Well, B says f of 6 equals n. So that means after 6 hours, the temperature, we don't know it, but we can say the temp is n degrees Fahrenheit. And the last one. F of 3, so 3 hours, 9 hours. What does this say? It says the temperature 3 hours after 6 a.m. So that means the temp at 9 a.m. is less than the temperature at, well, it's 9 hours after 6 a.m. So 9 hours after 6 a.m. is 3 p.m. So we know the temperature at 9 a.m. is less than the temp at 3 p.m. And that's how we can interpret our three things. In example 3, we're going to solve for the independent variable. What variable is always the independent one? It's x, or what you plug in. So here we go. Our equation, h of x equals 2/3 x minus 5. We want to find the value of x if h of x is equal to -7. So all we do is take the -7, plug it in for h of x. We get 2/3 x minus 5 equals -7, and now we just solve it. I add 5 to both sides by using the addition property of equality. I then multiply both sides by 3/2, the reciprocal, which is the multiplication property of equality, and that gives me x equals -6 divided by 2 would be -3. So what is the value of x? It's -3. In example 4, here we go. We're going to graph. We're going to graph this equation. F of x equals 2x plus 5. Here's the great news. We graph it the same way that we've graphed anything else. You can make a t-table, or you can make a graph using slope-intercept form. So since it's already in slope-intercept form, I'm going to graph it using the y-intercept of 5, the slope of 2 over 1, and there's my line. F of x equals 2x plus 5. Now we can solve a real-life problem. Example 5. The graph shows the number of miles a helicopter is from its destination after X hours on its first flight. On its second flight, the helicopter travels 50 miles farther and increases its speed by 25 miles per hour. The function, right here, f of x equals 350 minus 125x. That represents the second flight, where f of x is the number of miles the helicopter is from its destination after X hours. Which flight takes less time? Well, you could graph it. However, honestly, I would expect you to be able to use just common sense. Let's look at this. Right here, our first flight takes 3 hours. Our second flight starts at 350. So if you graphed it, let's just think about it. 350. And every hour, it goes down 125 miles per hour. So how long till you get to the end? Which obviously, this is what we need to find. We need to find the x-intercept. Now this is review from last year. Woohoo, review. How do you find the x-intercept? You plug in 0 for y. Well, in this case, we have f of x. So all we're going to do is plug in 0. 350 minus 125x. I add 125x, so equals 350. I divide, and I get what? I get 2.8. So this one takes 2.8 hours, and the first flight takes 3 hours. So which one is less time? The second flight takes the least amount of time.